Welcome back, folks. I didn't realize that the camera was still on, but whatever. I guess I'm here for this video. So what I want to do in this video is, investigate another property of the cross product. And so what I've done is, instead of kind of working through this picture, I've kind of taken that picture and kind of flattened it out. And we've just taken those two vectors, A and B, same vectors, and dropped it out right here. Okay. And we still have the cross product, which we calculated in the last video as 3, 9, 1. Okay. Now, we've seen before where we've taken these two vectors and I can add them. For example, I can draw in A plus B, and I can, just mirror A over here and then B over here, and I get this like funky parallelogram. Okay. Here's some food for thought: is what is the area of this parallelogram? Okay. A random question, and yeah, it kind of is random, but how would I figure it out? So we do need a couple pieces of information, because you can't get a parallelogram just from the sides, right? What we would need to know is the base and the height. So the area of a parallelogram is equal to base times height. So we actually have, say, the base, right? The base could be, say, the magnitude of A. That's not too bad, right? It's just the length of that vector A. But we need to figure out what the height is. So how can I figure out the height? Well, one thing that would be helpful, and maybe I can't get the height exactly, but if I knew the angle between the two vectors, I could get the height, right? If that's the case, then I could actually say that the height here, and I'll erase this, the height is simply the magnitude of B, in this case, times times sine of the angle. Right? This is actually going to look very, very similar, because now if I substitute this in, I'll have B times sine of the angle. Okay? So that looks actually a lot like the dot product. Unfortunately, the dot product is magnitude A, magnitude B, cosine of the angle. So I can't use the dot product here. However, I could use the dot product to find the angle, and then take sine of that angle, multiply it by these, and then get the area of this parallelogram. Okay, so I'm going to use my dot product here and just get the angle. I'm going to fast forward through that part because you should already be able to do it, but of course you should check my work when we come back. Alrighty, so we're back, and so what I've done is I've calculated the dot product. So on top, you can see here, and when I dot these two ones, it's really handy in this case because two of the components end up being 0. And the bottom, it turns out that, well, these two vectors actually have the same magnitude, and it's the square root of 10. So I get, 3 over 10, and that's equal to cosine of the angle. Take the inverse cosine of that, and I get about 72.54 degrees. For this experiment, I'm actually storing that value in my calculator. So yes, it rounds off to 72.54, but it, of course, goes on for a while. Okay, hang on to that. So now if I calculate the area of this parallelogram, okay, well, magnitude of A times magnitude B, so that's, well, root 10 times root 10, which is just 10, times sine of this angle now. So 72.54 degrees, and I'll get, when I do this, I end up getting, let's see, sine, that value times 10, and I end up getting about 9.5393, 539392014. So there's a reason I'm doing this all. And that's a number, it's whatever it is. Right? It probably goes on even longer than my calculator says. Okay. This might blow your mind. What I want you to do now is calculate the value. Sorry, I want to calculate the magnitude of the cross product. Okay. So just by saying that, you probably know what it's going to be, right? But I'm just going to calculate the magnitude of the cross product here, A cross B. So that's just going to be the square root of the components squared. So 3 squared, 9 squared, plus 1 squared. So that's the square root of 1091. So if I take the square root of 91, I'm going to get this, 9.539392014. That is not a coincidence. That is exactly what it's supposed to be. So yes, actually, these are the exact same value. The area of this parallelogram and we'll talk about like, you know, we'll see examples of like where that's actually relevant, is actually just simply the magnitude of the cross product, which is really, really cool. To prove this actually algebraically is actually pretty challenging and requires a couple like kind of funky algebra tricks. So I'm not going to do that in this video. I might try to find a video and show you there. But that's really the third property here that I want to bring about, is that the value of the cross product, or sorry, the magnitude of the cross product is actually equal to the magnitude of A times the magnitude of B sine of the angle between the two vectors. Again, contrast that with the dot product, where A dot B is equal to A magnitude B times the cosine of the angle. Alrighty? Pretty darn cool, in my opinion. Seemingly random, but it, you know, again, the more properties that we can dig out of this, like, again, super random process for creating a cross product, right? You take the two vectors, you calculate this like 3x3 determinant thing, and it turns out it has all these really interesting properties. It's just something that I find like really interesting. Okay, so thanks for hanging out and thanks for watching this video, and I'll see you in the next one.